The United States Navy unveiled its goals and specifications for its next-generation destroyer late last week. This vessel will replace any remaining Ticonderoga cruisers and some Burke destroyers, making it an obviously important vessel given the potential need to replace dozens of hulls. There were also many technical details provided, but before we get into those, let's examine how crucial the DDG-X program is. Guided Missile Destroyer, DDG, an unknown design, X. Entire schedule began in earnest in June 2021, when the Navy established a DDG-X office to oversee the project. The office is responsible for the overall acquisition plan and ship construction. The current target dates for the first building contract are 2028, and the first ship is scheduled to be commissioned in 2032. DDG-X itself is at least 5 years late, as the original contract signing year was 2023, but the Navy couldn't agree on what they wanted back then. It appears that the requirements have tightened up recently, and the Navy isn't involved in this time for the stars, but it needs a system with tried and true answers first. A well-known hull type was used to evaluate propulsion mechanisms and onboard electronics. As time is of the essence for the U.S. Navy to match the construction rates of the Chinese Navy, the service is hesitant to take any major risks. This version of a destroyer appears to have a chance of seeing the light of day after decades were spent on failed high-tech projects. It's true that some of the Ticonderoga cruisers will need to be retired well before 2030. We can't keep delaying and restarting another next-generation destroyer program while the first Burke ships are still in development. This year will mark the beginning of the preliminary design phase for the DDG-X. However, once a naval architecture firm is selected and tasked with engineering the ship, a final chosen and defined design and detailed design is due by 2026, so the image that the U.S. Navy disclosed is still not necessarily the final chosen and defined design. The design will then be put to the test, and some shipyards will have to qualify for the actual work before the final shipbuilding contract is signed in 2028. The Navy office defines and publishes a set of guidelines for the ship to follow. The ship must have a greater missile capacity than the Burke-class destroyers, with anti-ship and ground strike missiles that are both larger and more capable. The newest Burke destroyer variant, Flight 3, will be integrated into the ship's combat systems. Even though the new hull is distinct from the Burke destroyer, it may still draw inspiration from the research done on the Zumwalt-class hull. Navy officials released a photo of a ship resembling the Zumwalt class, but with a more traditional flared frontal hull section, suggesting that this may be a test vessel rather than the final design. If the final displacement is somewhere in the middle, we could end up with a ship of around 13,000 tons. However, the Navy anticipates a hull smaller than Zumwalt's, which is very close to the predicted size of China's newest class of destroyers, the O-55 class. Included in these planned combat systems were radars identical to those used by Burke Flight 3, making for a total of 4 large radar faces. Due to the modular nature of the Aegis system's new Spy-6 radars, larger radar faces with 57 array blocks may be installed in these destroyers by the 2030s. Raytheon, the radar's manufacturer, claims that the new models will be significantly more powerful and sensitive than current radar. That the 69-block radar phase could spot the target from 4 times the original Spy-1's distance, using a radar signature half as large. 2 or 3 rolling airframe missile systems for terminal self-defense will be included in the base ship configuration. These have been serving the same purpose as the phalanx guns they replaced for some time, but by the 2030s, the Navy expects the ship to have laser systems installed in place of the RAM systems. The Navy has projected 2 different laser systems, the larger of which is 151 kilowatt, a laser very similar to those recently tested by the Navy. At least one of those terminal defense systems is likely to be a laser system by the time the first ship enters servers. In the meantime, the Navy expects the ship's 600 kilowatt lasers to meet all of the ship's terminal defense requirements. In terms of cost-effectiveness and usability, they are still light years behind the state-of-the-art. There will be more room in the hangar than on the Burke destroyer. The future destroyer will have a 3rd helicopter on board, an unmanned one for reconnaissance in addition to Burke's 2 Seahawk helicopters. The Navy diagram also shows a component called the Destroyer Payload Module located amidships. While the Navy can store vertical missile launch cells in such a module, they would prefer to have flexibility. VLS cells up front, and room for 64 more inside the destroyer's payload module among the ships. That's in line with the Navy's claim that the future destroyer will be able to carry more missiles, and it's more than the Burke destroyer has. Mark 41 missile cells, however, will be interchangeable with larger missile cells in the future to give the Navy more flexibility. The Navy believes that 12 large missile cells can replace 32 Mark 41 cells. Even intercontinental ballistic missiles, ICBMs, would likely be intercepted in mid-course by a hypersonic weapon like a ground strike missile or an anti-ship missile or a missile designed to enter an aircraft. The ship's thrusters will be powered by a centralized energy system. The Navy has stated that the integrated power system of the future Columbia-class submarines will benefit from the lessons learned from Zumwalt propulsion. Generators powered by gas turbines, the ship's lights, computers, radars, and weapons, as well as the electric motors that turn the ship's propeller shafts, are all powered by this electrical system. Modern ships can't function without these kinds of electrical power plants, as radars and lasers consume vast amounts of energy. The Navy plans to use advanced controls to store and distribute electric energy through those IPS systems in the not-too-distant future. In that case, the ship would have massive batteries that make the gas turbines less vulnerable. This would help the ship to be more fuel efficient, which in turn translates to greater range and time on station. Indeed, the Navy gave out expected figures for those. The DDGS is to feature 50% longer range than the Burke destroyer, and as much as 120% longer time on station. Given that we are talking about the big heavy hull, these are some extremely impressive figures. REMA. The Navy expects to spend billions to complete the development and build the first ship, which is essentially the prototype, which is a huge figure but still less than the doomed Zumwalt destroyer, whose entire program cost $9. Research and development alone cost $6 billion, and building all three ships cost another $13 billion. The Navy expects the per-ship cost to decrease to no more than $2.5 billion by the time the 10th DDGX is built. In fact, the Congressional Budget Office projected the average procurement cost per DDGX ship in 2021 to be $2. In the same year's dollars, $9 billion would be equivalent to 3 Zumwalt-class destroyers or 2 Burke-class destroyers currently under construction. Let's try to analyze the image, even though it might not be representative of the final design as defined by the Navy. The Zumwalt's hull had a tumble-home design, which was necessary for stealth but was sometimes criticized for its potential lack of stability in certain sea conditions. However, stealthy shaping is given much less attention in the DDGX illustration. Appearance of the future: the radar cross-section of Zumwalt's destroyers had to be 50 times smaller than that of some earlier models. In reality, the difference is closer to 12 times, and modern radars offer a few times larger detection distances compared to radars of the 1980s, so don't let the seemingly large number fool you. In fact, the Swedish Uri AVAX radar was advertised as being able to detect and follow even the smallest jet skis from a distance of over 200 kilometers. Excellent justification for the Navy's apparent abandonment of ultra-stealthy ship technology. Like per class, the ship depicted in the illustration has a distributed radar array built into the ship's superstructure. However, unlike the new Japanese destroyers or the older Tycho cruisers, only 2 radar faces are integrated above the helicopter hangar, which is too far away from those above the bridge. In a further homage to it appears that all the other radar arrays have been incorporated there as well. The Zumwalt destroyer took a different approach than the Burke-class destroyer or the current Chinese destroyers by placing the arrays above the bridge fairly high up, allowing for somewhat longer detection ranges against low-flying incoming missiles. Due to the ship's electric propulsion, not only are the radar arrays spread out, but it also appears that half of the turbines are located far below the helicopter hangar, making it unlikely that a single hit will destroy all of them. In conclusion, this is still very early in development, but the Navy has made it clear that they want the ship as soon as possible, even if that means it enters service not much better equipped than the current ships, while at the same time, certain technologies and design choices offer greater flexibility and capabilities for future upgrades. Thus, DDGX may be a vessel suitable for the technologies of the 2050s and beyond, not just the 2030s. But ship budgeting and unplanned cost are likely to continue to be its biggest foe.